Have you ever wondered where does the elements of the periodic table come from? Earth's crust is a satisfying answer. It's surely where the supply lab gets them. But how did the Earth's crust acquire them? The answer must be astronomical. But in this case, do you actually need to know the origin and evolution of the universe to answer the question? Yes. Yes, you do. Only 3 of the naturally occurring elements were manufactured in the Big Bang. The rest were forged in high-temperature hearts and explosive remains of dying stars, enabling subsequent generations of star systems to incorporate this enrichment, forming planets, and in our case, people. Yet, every now and then, how else could we believe that sodium is a poisonous, reactive metal that you can cut with a butter knife? While pure chlorine is a smelly, deadly gas, yet when added together, they make sodium chloride, a harmless, biologically essential compound better known as table salt. Or how about hydrogen and oxygen? One is an explosive gas and the other promotes violent combustion. Yet the two combined make liquid water which puts out fires. With only one proton in its nucleus, hydrogen is the lightest and simplest element made entirely during the Big Bang. Two-thirds of all the atoms in the human body are of hydrogen. Hydrogen in the core of the massive planet Jupiter is under so much pressure that it behaves more like a conductive metal than a gas, creating the strongest magnetic field among the planets. Every second of every day, 4.5 billion tons of fast-moving hydrogen nuclei are turned into energy as they slam together to make helium within the 15 million degree core of the Sun. Some 30 years before it was discovered and isolated on Earth, astronomers detected helium in the spectrum of the Sun's corona during the total eclipse of 1868. Lithium is the third simplest element in the universe, with 3 protons in its nucleus. But unlike helium, which can be manufactured in stellar cores, lithium is destroyed by every known nuclear reaction. The element carbon, given the abundance in the cosmos, a better element does not exist on which to base the chemistry and diversity of life. Both oxygen and carbon are major ingredients of life as we know it. Aluminium occupies nearly 10% of Earth's crust, yet was unknown to the ancients and unfamiliar to our great-grandparents. The element was not isolated and identified until 1827 and did not enter common household use until the late 1960s. By many measures, iron ranks as the most important element in the universe, with 26 protons and at least as many neutrons in its nucleus. Iron's odd distinction comes from having the least total energy per nuclear particle of any element. This means something quite simple. If you split iron atoms via fission, they will absorb energy, and if you combine iron atoms via fusion, they will also absorb energy. As high-mass stars manufacture and accumulate iron in their cores, they are nearing death. Without a fertile source of energy, the star collapses under its own weight and instantly rebounds in a supernova explosion, outshining a billion suns for more than a week.